Okay. We've got a point P. Its coordinates are -1, -4, is a terminal point of angle theta. And so that means that that point is on the terminal arm of an angle, and that angle is in standard position. So now you have to find out what sine of theta, cos of theta, tan of theta, secant theta, cosecant theta, and cotangent theta. Again, by teaching you a new idea, all of a sudden, a lot of questions get opened up. So technically, you have all the skills to solve this one already. But this question is going to get you to understand your cast rule, your reference angles, angles in standard position. All of those definitions come together in this question. So if I look at where -1, -4 is, and if that's on the terminal arm of an angle theta in standard position, theta would be this angle here. Okay? And apparently, we have enough information to say what sine of theta is without a calculator. Okay? So what do we need to do? We need, if we're doing sine, cos, and tan, opposite over hypotenuse, we need a triangle. Where do we make our triangle? We make our triangle always back to the nearest x-axis so that we can label this little angle in here as our reference angle. And if I draw that triangle back to the x-axis, can you tell me what the side lengths of that triangle are? How long is this side? Well, how long? 1 unit long. Okay? So yes, we're going 1 to the left, but if we're actually thinking about the length of that, it's 1 unit. What about this one here? 4 units. What about the hypotenuse? Someone's saying square root of, and then there are a bunch of... Okay? You will be able to do, we are going to do a squared plus b squared equals c squared so much, and you will do it mostly in your head. Are you okay to do 4 squared plus 1 squared to get 17, and then square root it right away? If you want to show the work, okay, you can. And now we can go and say, I have a triangle. What is sine of my reference angle would be opposite over hypotenuse. So sine of theta will be 4 over root 17, but we're also going to think about, hey, that's in quadrant 3. Sine is negative in quadrant 3. Grade 11, what did you have to do when you had a square root on the bottom? Rationalize the denominator. In grade 12, they assume that you can do that. You've learned it in grade 11. Okay? So in grade 12, you can leave a square root on the bottom and not lose any marks. Okay? Okay? However, they assume you know how to do that. If it was a multiple choice question, the multiple choice question would probably have the answer as -4 root 17 over 17. So you still need to know how to change it from one to the other. Okay? Do you remember how to do that? You would multiply top and bottom by square root of 17. You can leave the square root on the bottom. Grade 12, welcome to grade 12. We assume you know how to do things. And so you don't lose marks. Okay? Assumed wrong. What would you have to do if your answer was 9 over 12 in grade 11? What would you have? How would you have to write your answer? Right, you have to write it as 3 over 4. You have to reduce it to lowest terms. Okay? Grade 12, they assume you know how to do that. If you leave it as 9 over 12, full marks. Okay? Oh, it's so easy, this course. Yeah, just wait. If you reduce it and make a mistake, then you lose marks. Sometimes it's better just to say, okay, I know I could reduce it. I'm not going to. Everybody know how to reduce fractions on your calculator? Like if you had like 45 divided by 312, you're like, ooh, that's a little bit tough for me to reduce. You type it in your calculator, push enter, gives you that decimal, and then you go math, I'll change it back to a fraction, and when you change it back to a fraction, it reduces it to lowest terms for you. That is kind of nice. Kind of nice. I wish I would have known this earlier kind of nice thing, but yeah. Well, you don't need to. You could leave it as 45 over 312, or you could make it reduce. Anybody know how I randomly picked a number like, if I pick 462 and I divide it by 6543912, that I know that that reduces? Oh, they're both even. Okay, I don't want them both even. There, they both still reduce. Why? I picked numbers that were both divisible by 3. Does anyone know how you can tell if a number is divisible by 3? You add up the digits. What's 4 plus 6 plus 2? 12. If 12 is divisible by 3, then 462 is divisible by 3, which is kind of cool. And this one, a lot of adding here. 11, 15, 18, 27, 28, 33. 33 divides by 3, so the whole thing is divisible by 3. So if I push enter, now sometimes your calculator runs out of thinking ability, so I'm not sure if this is too big of a number for it to reduce back to a fraction. It is. But you can do a quick check. 462 divided by 3 does simplify, and 6543915 divided by 3 also simplifies. 154 would divide by 3 again. Let's see what here we have. 3, 11, 12, 15, 20. That number doesn't divide by 3. So that adding them up to check if it divides works for 3 and 9. So there's tricks in there. Okay. There's a trick for figuring out that you can divide that number by 11. Sorry, I'm getting off topic. This is just fun. Does it divide by 11? Yes, it does. How did I know that? With 11. Because I memorized this number beforehand. With 11, you can add, subtract, add, subtract, add. And if the number you get is divisible by 11 after you do that, it's divisible by 11. 8 minus 1 is 7, plus 3 is 10, minus 2 is 8, plus 3 is 11. It divides by 11. 9 minus 1 is 8, plus 9 is 17, minus 1 is 16, plus 9 is 25, minus 3 is 22. 22 divides by 11. That works out perfectly. Okay, sorry. We did sine of theta. We can do cos of theta. Cos of theta would be adjacent over hypotenuse. It's in quadrant 3, and it will be negative. Tan of theta. Tan of theta is opposite over adjacent. And it's in quadrant 3, so it'll be positive. And you could leave it as 4 over 1. You could write just 4. That would be fine as well. Those are the 3 primary ones. And now for the reciprocal ones. So the reciprocal of sine is cosecant. And for the reciprocal, if sine is negative 4 over root 17, and cosecant is a reciprocal means a fraction flips. So the answer for cosecant will be root 17 over negative 4. And it doesn't matter where you put the negative. A fraction, you can have, like, negative 1/2 is the same as 1 over negative 2, which is the same as the negative in front. You can choose where you put that negative. So secant of theta, which is the reciprocal of cos, will be negative root 17 over 1. You could write the over 1 if you wanted to. You wouldn't need to. And cotangent of theta will be 1 over 4. So we're really working with a lot of our definitions in this question. Okay? I like to call these ones triangle questions because you're dealing with trigonometry and you need to draw a triangle. Once you've got a point, you can always draw a triangle with that point. Now, the triangle that you need to draw has to include your reference angle. So your triangle is always back to the nearest x-axis because that's where your reference angle is. Because what we did earlier and what we noticed, that sine of 30 degrees was the same as sine of 150 degrees. And sine of 330 degrees was the same number as sine of 30 degrees because they have the same reference angle. The only thing that changes is sometimes it's positive, sometimes it's negative. And that's connected to your cast rule. So when you draw your triangle with your reference angle, that just takes you back to grade 10 trig. Just regular SOHCAHTOA, no negatives, no worries about anything. A squared plus b squared equals c squared. Easily to see, oh, sine is 4 over root 17. But now, since it's in quadrant 3, it's negative. And you can find all of them from that triangle. Okay, questions for practice on this one? Number 8.